Have you ever looked at a bunch of matrices and a final answer and just felt lost, like you've been handed a puzzle but all the pieces are scrambled? Well, today we're putting on our detective hats. We are going to crack the code on matrix multiplication, not with a calculator, but with pure, sharp-eyed deduction. So let's get into it.
So, here's our central mystery. You've got your target, this matrix X, and a list of suspects, A, B, and C. The big question is, in what exact order do they multiply to give us our answer? It looks tough, I know, but trust me, every good detective knows there's a logic to even the messiest crime scene.
All right, welcome to the investigation. The key to this whole puzzle isn't about doing a ton of math. No, it's about understanding the rules of the game. And our secret weapon? It's a technique called conformability assessment.
So what is this master tool exactly? Well, conformability assessment is really just a fancy way of saying we're checking if matrices are even compatible. Can they even be multiplied together? For any two matrices, the number of columns in the first one must match the number of rows in the second. This simple check, it's the foundation of our entire detective method. Now for our first huge clue. And honestly, this is a total game changer. The very first matrix in the chain, the one that kicks the whole thing off, it's always going to have the same number of rows as our final answer, matrix X. This clue alone lets us immediately narrow down our list of suspects for who started this whole thing.
And here's our second crucial clue. This one helps us nail down the last piece of the puzzle. The very last matrix in the sequence will have the same number of columns as our final product X. Think about that for a second. With just these two rules, we can figure out the beginning and the end of the sequence before we've even thought about the middle.
All right, detective, it's time to put these new skills to the test. Let's solve our first case and see this method in action.
Okay, here's the case file. Our target, matrix X, is a 1 by 1. Our suspects are A, a 5 by 3, B, a 3 by 1, and C, a 1 by 5. The absolute best place to start is always with the dimensions of our answer, matrix X. So, let's apply our rules. The first matrix must have one row, just like X. A quick scan of our suspects shows only one candidate, matrix C, which is a 1 by 5. Easy enough. Now, the last matrix must have one column, again, just like X, and that's got to be matrix B, our 3 by 1. Just like that, we found our bookends. Okay, so we know C is first and B is last. That means A has to be in the middle. But let's check it, just to be sure. Can we multiply C by A? Well, C is a 1 by 5, and A is a 5 by 3. We look at those inner dimensions, 5 and 5. It's a perfect match. So multiplying them will work, and it'll give us a new intermediate matrix, CA, with dimensions of 1 by 3. Now for the final link in the chain. We take that new matrix, CA, which is a 1 by 3, and see if it can be multiplied by our last matrix, B, which is a 3 by 1. Look at those inner dimensions again. 3 and 3, another perfect match. The result is a final matrix, CAB, with the dimensions of 1 by 1. And that is exactly what we were looking for. It's a match for X.
And just like that, case closed. The only possible sequence is C times A times B. Now, did you notice something amazing here? We solved it the entire puzzle without multiplying a single number inside those matrices. It was all pure logic and deduction. Okay, that first case was a great warm-up, right? But what happens when the clues aren't so clear? What if our initial deductions point to multiple suspects for the middle of the sequence? Let's take on a tougher case.
All right, here's our new file. Our target, X, is a 3 by 4 matrix. And this time, we've got 4 suspects, A, B, C, and D, all with their own dimensions. The procedure is exactly the same, though, so let's start by looking at X.
Let's apply our rules. The first matrix has to have 3 rows. Looking at our list, that's got to be matrix C. The last one needs 4 columns. That's definitely matrix B. So we've got our start and our end. But now we have a problem. We have 2 suspects left for the middle, A and D. So how do we figure out the real sequence? This leaves us with 2 potential culprits, 2 possible paths. The right answer could be CAB or it could be CDB. To get to the truth, we're going to have to investigate both of them.
Now this is where the case gets really interesting. Let's check the dimensions for both paths. If we try C times A, we get a 3 by 3, which can then be multiplied by B to get a 3 by 4. Okay, so that works. But wait, If we try C times D, we also get a 3 by 3, which can also be multiplied by B to get a 3 by 4. They both work. They're both conformable. Our deduction has taken us as far as it can go. Now, and only now, do we actually have to look at the numbers inside the matrices.
So we run the numbers on our first suspect, the sequence CAB. We do the actual multiplication step by step, and when we compare that final result to our target, matrix X, the numbers don't match up. This means CAB is an imposter. We can officially eliminate that lead.
And you know what that means? Since there was only one other possibility, we found our answer without even doing the second calculation. By process of elimination, the correct sequence must be CDB. The evidence is conclusive. Case cracked.
So, let's just step back for a second and appreciate what we've accomplished here. We've developed a really powerful, super efficient shortcut for solving these complex matrix puzzles.
The secret, the real takeaway from all of this, is that the smartest way to tackle these problems is through deduction, not calculation. By using the rules of conformability, you can solve the sequence puzzle with logic. You'll save a ton of time and avoid making silly calculation mistakes.
And here it is, boiled down into 3 simple steps. Your detective method. Step 1. Examine your target, matrix X. Step 2. Use its dimensions to identify the first and last matrices in the chain. And step 3. Build that chain from the inside out, testing for conformability until you find the one true path.
You now have the complete toolkit of a matrix detective. You can see the patterns, you can follow the clues, and you can solve the case without breaking a sweat. So, with this new power of deduction, the only real question left is, what mystery are you going to solve next?